right now, almost half of global IT leaders admit they're basically flying completely blind.
Yeah, totally blind. It's a huge issue.
Like, they have absolutely no idea where all their enterprise data is being collected or being stored.
Right.
Which brings us to our mission for today. Welcome to the deep dive, everyone.
Glad to be here.
We are taking a deep dive into fixing that exact architectural chaos. Specifically, we're looking at the actual technical advantages of combining HPE Storage, like the HPE Alletra, with HPE Servers, like the ProLiant line.
Right, because we really want to know why standardizing on that unified stack is fundamentally different from, just piecing together a data center with third-party storage.
Exactly. And we're pulling from a massive stack of HPE technical resources today to figure this out.
We're going to unpack how matching these layers unlocks this deep cross-stack analytics capability.
Why is the mix and match approach so problematic? Like, it reminds me of setting up a high-end home theater.
Oh, I know where this is going.
Right. You buy an incredible television from one brand, surround sound speakers from another, and a receiver from a third.
And now, just to watch a single movie, you're juggling like 3 different remote controls.
Exactly.
Because the devices speak completely different digital languages.
Yeah, and I mean, it works fine when everything is perfectly tuned, but the moment the audio drops out, you're sitting there staring at 3 remotes with absolutely no idea which box is at fault.
Right. Is the TV dropping the output? Or
is the receiver misinterpreting the input, or is the speaker wire just loose? You just don't know.
translate that to an enterprise environment, and you start to understand the daily nightmare for IT admins.
Oh, I can only imagine.
When your compute and your third-party storage don't share a native management plane, you are basically building an infrastructure that requires multiple remote controls.
So you just lose visibility across the board.
You lose visibility, yeah. And that manual correlation is where the real business liability comes in.
Ah, right. Let's talk about that liability.
Because when you have disconnected hardware, proving to an auditor that a specific data set is secured end-to-end is incredibly difficult.
So the multiple remotes problem isn't just an IT headache. I mean, it is a massive financial risk.
Exactly.
But if the root problem is a lack of unified visibility, how does standardizing on HPE hardware actually solve it? Because, let's be real, every vendor claims they have a single pane of glass.
Oh, sure, they all say that. But the difference comes down to where the telemetry data is being gathered and how it's analyzed.
Okay, unpack that for me.
This is where HPE InfoSight comes in. It's their artificial intelligence for IT operations, or, their AI ops platform.
Right.
When you combine HPE ProLiant servers with HPE Alletra storage, InfoSight isn't just looking at the storage array, it's pulling telemetry from the entire infrastructure stack.
Okay, give me a practical example of how that plays out for you, the listener, if you're running this stuff. Let's say I'm running a mission-critical database on a server, and it's hooked up to a standard third-party storage array.
Okay.
Suddenly, the application just slows to a crawl. What happens?
Well, in that scenario, the third-party storage array only knows what is happening at its own front door, essentially.
Right.
It looks at its internal metrics and says, hey, I'm delivering data perfectly fine at sub-millisecond latency. Not my problem.
Not my problem. But your database is still lagging.
Exactly. The storage is completely blind to the fact that the bottleneck might be a CPU queue on the server, or maybe a misconfigured virtual machine in VMware.
So the admin is just back to digging through logs manually.
Yep. But with the unified HPE stack, InfoSight sees both sides of that equation simultaneously.
Wait, really? It sees all of it?
It sees the storage, the network fabric, the compute layer, and even into hypervisors like VMware. It correlates the data instantly. The sources actually note that HPE AIOps automatically predicts and resolves 86% of problems before the user even realizes there is an issue.
Okay, I have to pause you there because 86% sounds suspiciously like a polished marketing metric.
I know, it sounds high.
Like, how is a software platform actually predicting a physical or software failure before my application crashes? What is the actual mechanism gathering that data?
That's a totally fair question. The engine behind that prediction is something called the Active Health System, or AHS.
Active Health System,
Yes.
okay.
Yeah, and AHS is built directly into the silicon of the HPE servers. It provides continuous, agentless monitoring of thousands of server parameters.
Hang on, unpack agentless for me. Why does that matter?
Okay, so traditional monitoring tools require you to install an agent, basically a piece of software, onto your operating system.
Right, I've seen that.
That agent consumes your CPU and RAM just to run its checks. meaning your monitoring tool is actively stealing resources from your actual applications.
Which defeats the purpose if you're trying to maximize performance.
Exactly. But AHS doesn't do that. It runs completely out of band on its own dedicated management processor.
Oh, so it's separate.
Totally separate. It logs every single hardware change, configuration shift, and thermal event with atomic precision, and it does it without stealing a single cycle from your database.
That's impressive.
And then InfoSight takes that massive stream of clean data and applies machine learning to it.
Okay, let me push back again, though.
Go for it.
If I am talking to a third-party storage vendor, they're going to say, we have predictive AI ops too. We use machine learning.
Right.
So why isn't their AI just as good?
Because the boundary of their intelligence is strictly limited to their own hardware. Third-party AI ops might be incredibly smart about their own hard drives, sure, but they are completely blind to the rest of the room.
Like the TV remote that has no idea what the receiver's doing.
Exactly. Perfect analogy.
Mm-hmm.
Furthermore, InfoSight learns from a global installed base of both compute and storage.
What do you mean by global installed base?
Imagine a server in Tokyo encounters a highly obscure hypervisor bug that causes storage latency to spike under a very specific load.
Oh.
InfoSight recognizes that pattern, creates a signature for it, and instantly applies that knowledge to your servers in New York.
Oh, wow.
Yeah, it basically inoculates your infrastructure against problems you haven't even encountered yet.
So because it sees the whole stack globally, it can actually map cause and effect across different hardware layers.
Precisely.
That makes sense. But let's say the AI does its job perfectly, and it tells me that my application is slow simply because I am, well, just out of physical storage capacity.
Right, you just need more space.
Yeah, I mean, AI cannot rewrite reality. I still have to buy more hardware. And traditionally, scaling compute and storage gets very messy very fast.
It does. This brings us to physical architecture.
Yeah.
If you use third-party storage, or if you use traditional hyperconverged infrastructure, often called HCI, you are going to hit strict physical and financial walls.
Let's dig into the storage itself, actually, because the sources mention some features that sound, frankly, a bit like magic.
Let's hear them.
For example, it mentions always-on data reduction, delivering up to 5 times space savings. And it says they use write serialization to write to cost-optimized disks at flash speeds, defying the physics of mechanical spindles.
That is quite a sentence.
Right. Give me the actual technical reality behind defying physics. Like, how does write serialization actually work?
Well, ignore the marketing phrase for a second. The physics are very real. Traditional storage takes random data blocks from your applications and tries to write them to the disks exactly as they come in. Now, if those are mechanical disks, the read-write head has to physically jump around the platter to write all that scattered data, which introduces massive latency.
Because physical movement literally takes time.
Precisely. What write serialization does is take all those scattered random inbound writes and catch them in a high-speed memory cache first.
Oh, so it acts like a buffer.
Exactly. It organizes them, packs them tightly together, and then writes them down to the underlying disks in one massive sequential continuous stripe.
It essentially turns random chaotic traffic into a high-speed bullet train.
That's exactly it. So you get the performance of expensive flash drives, even if you are utilizing high-capacity, lower-cost media underneath.
Okay, that explains the speed.
Yeah.
But what about the durability? Because the sources also highlight something called triple plus parity RAID.
Yes.
They claim it can tolerate 3 simultaneous drive failures with 0 performance impact. Tolerating 3 drives dying at the exact same moment sounds great, but usually parity comes at a heavy cost. Like, how much of my usable capacity am I burning to achieve that? And how does parity actually rebuild data on the fly without tanking the system's performance?
It's actually a brilliant mathematical solution. Instead of just mirroring your data, which you're right, would cut your usable capacity directly and have parity, uses XOR logic gates.
XOR logic gates. Math, not mirroring.
Right. Math. It looks at the data across your drives and calculates a mathematical equation. Say if it would be, but because the HPE Alletra controllers have dedicated hardware specifically designed to process those XOR calculations in real time, 3 drives can just vanish. The math reconstructs the data instantly for the user,
Right.
and the application doesn't drop a single packet.
Wow.
And the overhead is surprisingly low compared to traditional mirroring, meaning you keep the vast majority of your raw capacity.
That's incredible. If you, listening right now, are the IT admin responsible for a global fleet of this hardware, how are you actually interfacing with it? We know the multiple remotes are gone, but what actually replaces them?
What replaces them is the HPE GreenLake Cloud Operational Experience.
GreenLake.
Yeah, it is a single, unified, cloud-based management console for both the compute and the storage layers.
Now, when you say cloud management, let's clarify that for everyone. We are not talking about moving all of the enterprise's private data into a public cloud data center like AWS or Azure.
Not at all. The data stays safely on your own physical ProLiant servers and Alletra arrays, whether they're sitting in your basement, at an edge location like a retail store, or in a co-location facility.
Okay, good. So what does GreenLake actually do then?
What GreenLake does is bring the simplicity of cloud management to your on-premises hardware.
What does that look like in practice for the admin, like day to day?
It looks like intent-based provisioning. Let's say you need to spin up a new virtualized environment. Historically, you'd have to consult spreadsheets, check which servers have available RAM, check the storage arrays for available IOPS, and then manually map the storage logical unit numbers to the hypervisor.
A lot of manual checking.
Right. With GreenLake, you simply tell the AI your intent. You just say, I need this much capacity for a database workload with a strict backup policy.
And it does it.
The AI analyzes your entire global fleet and automatically recommends the best suited physical hardware for that specific task, and then it executes the provisioning in seconds.
It turns the admin from an assembly line worker into a high-level architect.
Exactly.
But let me contrast that with the competitor pitch,
Okay.
because a lot of major competitors argue that true unified management means putting your storage natively into the public cloud. They just tell you to rent the storage from the hyperscalers.
Yeah, that is what we call the public cloud trap.
It's a trap. Why?
Because storing massive amounts of data natively in the public cloud introduces a brutal economic reality: egress charges.
Egress, moving data out.
Right. Moving data into the public cloud is usually free. But the moment you want to pull your own data out, perhaps to run it through a new on-premises AI model, the cloud provider charges you an exorbitant fee per gigabyte.
It creates total vendor lock-in.
It does. And from an operational standpoint, if you move your storage to the public cloud but keep some compute on-premise, you haven't solved the multiple remotes problem. You've just geographically relocated it.
That's a great point.
HPE's approach keeps your data under your physical control, avoiding those egress fees, while still giving you the sauce-based management interface everyone loves about the cloud.
Okay, let me throw an extreme edge case at you then.
Bring it on.
What if you, our listener, operate a highly secure environment, say a defense contracting facility or a classified government dark site?
Okay, a dark site.
By law, those racks cannot have a connection to the outside internet. You literally can't use a GreenLake cloud portal. Does the entire HPE unified management argument just fall apart if the internet cord is cut?
No, it adapts.
Yeah.
If cloud-based management is strictly prohibited by security policies, the HPE stack is still deeply integrated on premises.
How?
Well, for fleet management, there is HPE OneView, which provides software-defined templates to deploy resources locally without ever reaching out to the internet.
Oh, nice.
And at the individual server level, you rely on ILO integrated lights out.
ILO. Right, ILO is essentially a tiny independent computer built right onto the server's motherboard.
Yeah, exactly. It has its own network port and its own processor. Even if the server's operating system crashes or the server is completely powered off, ILO allows the admin to log in securely, monitor thermal sensors, check for silicon-level security breaches, and reboot the system.
So the dark site is completely covered, even without the cloud.
Exactly. Fully covered.
So over the next 5 years, will the traditional hybrid by accident data center even be capable of surviving that stress test? Or is a tightly unified, self-aware, cross-communicating infrastructure no longer just a luxury, but the baseline requirement for staying in business?
Honestly, given the cost of downtime and those regulatory fines we talked about, I'd argue the unified stack is the only viable path forward.
So take a hard look at your own server racks. Look at the logos. Trace the cables. Ask yourself, how much are those boxes truly communicating with one another? Do you have a perfectly tuned machine, or are you just gripping 3 different remotes and praying the audio doesn't drop out?
That's all for today's deep dive. We will catch you on the next one.